Hey Lexi girl. All right, here is a problem that you gave me for the GRE practice. It says a machine is made up of two components, A and B. Each component either works or fails. The failure or non-failure of one component is independent of the failure or non-failure of the other component. The machine works if at least one of the components works. If the probability that each component works is 2/3, what is the probability that the machine works? Okay, so with probability, there's some formulas that you should be familiar with. First probability would be the one, or the first equation, I should say. The probability that A or B occurs. A and B are just events. So in this case, A would be the event that component A works, and B would be the event that component B works. So whenever you have the probability that A or B occurs, the formula that you use would be the probability that A occurs plus the probability that B occurs minus the probability that A and B occur at the same time. Okay? So, in our problem, it's we're going to let A equal the event that component A works, and we're going to let B be the event that component B works, and we're going to let M be the event that in this case it's not the component. M is going to represent the machine. So M is the event that the machine works. Okay? So we have the formula, or we have a formula. We're going to need a couple more formulas in order to make this work. All right, so let's look at the problem now. It gives you some information about events A and B. It says that each component either works or fails. In other words, there's nothing else. Either you're going to work or you're not going to work. Okay, that's good to know. Also, it says that the failure or non-failure of either component, it's not dependent on each other. So in probability and statistics, when you're talking about independent events, that means that since A and B are independent, we know that the probability of A and B is always going to be equal to the probability of A times the probability of B. Okay? So we can alter our original formula. This is our original formula up here. We can now alter this by saying the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A times the probability of B. Now please note, Lexi, that this only occurs if the two events are independent. So they would have to clearly state that in the problem, or you would have to know by something that they've said in the problem that that is the case. All right, so We have our equation. Let's go on and look further on into the problem. The reason why I am using the probability of A or B is because right here in the problem, it says the machine works if at least one of the components works. So what that means, Lexi, is that the probability that the machine works is equal to the probability that A works or the probability that B works. And so that's what we've just found here. So the probability, that's equal to the probability of A plus the probability of B minus the probability of A times the probability of B. So they give you what the probabilities are. The probability that machine A works is going to be 2/3 because it says that the probability that each component works is 2/3. Plus the probability that component B works is 2/3 as well. Minus, we're going to multiply those together. 2/3 times 2/3. So we end up with, what's that, 4/3 minus 4/9. And when we find the least common denominator, which is 9, multiply the top and bottom of 4/3 by 3. That gives me 12/9 minus 4/9. And your answer should be 8/9.